Hello, we are going to discuss the gamma function today and how it's used. The gamma function is a continuous extension to the factorial function, which is only defined for non-negative integers. Where there are other continuous extensions to the factorial function, the gamma function is the only one that is convex for positive real numbers. So if you look at equation 1, you can see the gamma function and how it works. The gamma function satisfies the recursive property, and if you look at equation 2, you can see this, which can be provided using integration by parts and L'Hopital's rule. Note that the recursive relationship in equation 2 can be used to extend the definition of the gamma function to all real numbers except the non-positive integers. When alpha equals n, and n is a positive integer, then the gamma function is related to the factorial function, and that is equation 3. For specific values of alpha, exact values of gamma exist. For the positive integers, gamma n is also deemed by 3. The gamma function evaluated at alpha equals 1/2 is what we see with equation 4, so we can use real numbers there. The recursive relationship in equation 2 can be used to compute the value of the gamma function of all real numbers, except of course the non-positive integers, by knowing only the value of the gamma function between 1 and 2. And that's what you'd use equation 1 to do, and you would get numerous answers.